Hello, everyone. We have two lectures this week. This first one here, part one of week number 5, is measuring health and disease. And so we're moving into exploring study designs. Some of these may be familiar to you, others may be new. The purpose of reviewing and or getting exposure the first time to certain study designs is that it will help inform you as to the potential hierarchy of evidence that's available for your systematic review or for your scoping review. It'll help you to consider the strength of those studies and to also understand the potential weaknesses or limitations related to each of those studies. Now, the purpose of this lecture is to gain an understanding of the measures of disease or injury frequency, such as prevalence and incidence. Now, a lot of times people will use prevalence and incidence interchangeably. That's incorrect, and let's make sure that as we go through things today, we completely understand the differences between the two. First off, looking at health. What is health? Health is a state of complete physical, mental, and social well-being, and not merely the absence of disease. When doing epidemiologic studies, researchers need to define what health is and what disease is, or what an injury is. Some definitions in epidemiologic studies can be simple. Simple example being the disease is absent or the disease is present. An epidemiologist or a researcher doing an epidemiologic study would then categorize subjects based on the presence or lack thereof of a disease. Several measures of disease frequency are based on concepts of prevalence and incidence. Now, prevalence and incidence, they help us to answer questions like these. What proportion of a group of people has a condition? And at what rate do new cases arise in a defined population as time passes? We always have to understand or appreciate the population at risk. These are the people who are susceptible to disease or who are at risk for injury because of their particular exposure. When doing a study looking at injuries in high school athletes, for example, you would only include high school athletes in the population and not collegiate athletes. And that probably makes sense, right? You wouldn't include female subjects in a study involving the prostate. You most likely wouldn't include non-runners in a study looking at risk factors for running-related injuries. And you wouldn't include male subjects in a study looking at cervical cancer. So prevalence, these are those cross-sectional studies, predominantly cross-sectional. And what you're looking at is there is a fraction or some percentage of a group of people possessing a clinical condition or outcome at a given point in time. Now, point prevalence, this is the prevalence which is measured at a single point in time for each person. You could, for example, collect preseason injury information on college athletes and maybe do it during the preseason period, like I said. It doesn't have to be the same day of the week, but relatively in the same time period. You wouldn't collect, say, at the middle point and at the end and compare those with the beginning of the season. There is a different type of prevalence, a period prevalence, and this is a type of prevalence that accounts for all the cases that were present at any time during a specific period. So this looks at how many people have the disease or the condition of interest at the start of the study and over a course of a period of time. We'll see an example of that in a little bit. Incidence, these are also known as cohort studies, and these are a fraction or a proportion of a group of people initially free of the outcome of interest that develops over time. There are two types, cumulative incidence and incidence density, that we're going to explore. Measures of frequency are expressed as proportions, the number of cases in the numerator, number of patients experiencing the events, and the denominator, the number of people in whom the event could have occurred. Prevalence and incidence data become useful to clinicians and researchers when it is converted to rates. Rate is the number of cases divided by the corresponding number of people in the population at risk. It's expressed as cases per 10 to some nth power. For example, 10 per 1,000. So let's look specifically again at some examples of prevalence and incidence. And it's important to highlight here that even if you aren't reviewing epidemiologic studies, you're not doing something that is exploring rates or risk factors in a particular population, you're not doing a scoping review on something like that, you may still want to report rates and risk factors in your introduction. For example, in the introduction, you might discuss how 1 out of every 100,000 males experience condition X. And risk factors for this condition include X, Y, and Z. So point prevalence, again, that's a measure at a single point in time for each person. So a little example here. There are 200 individuals, 200 residents living in a skilled nursing home. And what we see here are 10 individuals who are impaired by a stroke at some point during January to December of 2014. What is the prevalence of individuals in June of 2014 who are impaired by a stroke? So you would just want to take a look and see if somebody has a line extending from a dot, that means that they're impaired with stroke. C means cured. Obviously, for this example, that's probably not true or representative. Obviously, people probably still have deficits if they survive. But for our example, just accept that C means that they've become cured with treatment. X means the individual has passed on. So how many people in June of 2014 within that skilled nursing home were impaired by a stroke? If you need to pause the recording to think about it, go ahead and do so, but I'll continue on now. As you look at it there, 7 people in June were impaired by a stroke out of 198. Why 198? Because 2 had passed on prior to the month of June. Doing the math, 7 divided by 198, and then if we then make it as a factor of 10th to some power, we could do it as 3.5 for residents out of 100 were impaired by stroke at that point in time. Now, period prevalence, this is kind of like a mix between point prevalence and incidence. So it's the proportion of a population that has the condition at some time during a given period of time. It includes people who already have the condition at the start of the period and those who acquire it during that period. So an example here, during a 1-year period of time, there were 20 pre-existing and 15 new cases of meningitis in the population. 35 cases out of 30,000 people in that population, doing the math, because we had 20 pre-existing and 15 new. You see what the math there is, 0.001166. And then we multiply it by some factor of 10, in this case 10,000, we're able to say that there are 11.67 cases per 10,000 people. That's the period prevalence over the course of a 1-year time period. Now, why wouldn't you just do an incidence study? Well, in this particular example, you would only have 15 cases instead of 35, because in an incidence study, the only people that are allowed to be monitored over that course of time are individuals that are disease or free of injury, disease-free or injury-free. So that's the benefit or the advantage of doing period prevalence for some conditions. It gives you an idea about how that condition is affecting that particular population. Lifetime prevalence, you might see in papers people writing the lifetime prevalence of low back pain is 80%. It's basically looking at the total number of persons known to have had the disease for at least some part of their lives. Now, several factors determine prevalence: the severity of the illness. If many people who develop a disease die within a short period of time, its prevalence is decreased. The duration of an illness. If a disease lasts a short time, its prevalence is lower than if it lasts a long time, because you're not potentially capturing people with the disease when you are conducting your study. And the number of new cases. If many people develop a disease, its prevalence is higher than if a few people do so. Take a moment here to look at factors that influence prevalence. These should make sense as to why prevalence would increase or decrease within a defined population. So I'm going to give about 5 seconds of dead air. When you hear dead air, pause the recording and read through these now. Okay, so I'm assuming that you had a chance to read through those. If any of those don't make sense, let me know. Otherwise, let's continue on. Now, why are prevalence studies needed? Prevalence studies can be influenced by many factors unrelated to the cause of the disease. Thus, prevalence studies do not provide strong evidence of causality. Prevalence studies are helpful in assessing the need for preventative action or planning health services. For example, prevalence of patella tendinopathy in elite male basketball players was reported to be 30 to 55% by Leon et al. Now, what a study like this does is it highlights the problem of patellar tendinopathy. Patellar tendinopathy can be a persistent problem. It may not cause time loss from sport, but it may impact performance. And it may be frustrating to the point that some athletes retire prematurely from sport because they have difficulty rehabilitating or recovering from it. We did a study in physical therapy a few years ago where we looked at the prevalence of patellar tendinopathy and patellar tendon abnormality in male collegiate basketball players. And so what we did is we invited basketball players from George Fox University and 6 or 7 different universities around the area. They came to our biomechanics lab. We put them through a variety of different tests. And one of the things we did was have them complete a survey about their tendon symptoms. And we did images. We got diagnostic ultrasound images of their patella tendon. And what we were able to report, things that you would find within a classic patellar tendinopathy study, is we were able to report percentages. For example, a majority of participants did not present with pain during palpation, or they did not have ultrasonographic evidence of patellar tendon abnormality. And then we also had other information about those who did present with ultrasound evidence. There's an ultrasound image at the top there. The arrows are pointing to the borders of the patella tendon coming off of the apex of the patella. And what you're looking for are blackened or dark areas. These are the hypoechoic regions that illustrate failed healing response or collagen remodeling. The figure 2, that just focuses on the ultrasound, doesn't focus on the palpation or the survey that we gave them. This was just looking at tendon abnormality presentation. So very common setup there. You might also find potential risk illustrated. Now, prevalence studies, again, are not good at illustrating or demonstrating causality, but you can report a prevalence odds ratio. And so there was only one significant finding here. And this is interesting that non-starters were at a greater risk of having patellar tendinopathy or the presentation of patellar tendon abnormality compared to starters. Incidence studies. Again, these are the fraction or proportion of a group of people that were initially free of the outcome of interest that develops the condition over a given time period. Incidence, then, is the new cases of disease occurring in a population initially free of the disease or new outcomes, such as symptoms or complications occurring in patients with a disease who are initially free of these problems. Incidence is calculated by the number of new events in a period of time divided by the number of persons exposed to risk during this period. Cumulative incidence, that's the number of new cases of a disease during a given time period divided by the total population at risk. So if we were going to look at a group of runners, the cumulative incidence here, looking at patellofemoral pain syndrome among high school runners, and there are 5 runners here, and 2 of them developed patellofemoral pain syndrome. You would then say that there were 2 cases divided by 5 runners, that's 40%, 40 per 100 runners. So out of every 100 runners, 40 have patellofemoral pain syndrome. Now, that seems really high, doesn't it? Of course, this is just a made-up example, but there's a way to maybe get a more valuable number, and that's incidence density. This is the number of new cases of a disease during a given period of time divided by the total person time of observation. In the numerator, you have the number of new cases in the population. In the denominator, the sum of each of the individuals' time at risk and that time period that they were free from disease. This is a more precise measure of incidence. So now, if we looked at those same athletes, we could account for their total time at risk. Like runner 1 participated for 2 years. Runner 2 participated for 3 years, but at year 3 became injured, and so that's where you would stop tracking them. Runner 3, 5 years, runner 4, 4 years, and runner 5 was able to go 2.5 years before injury. So now, what is the incidence, that incidence density of patellofemoral pain syndrome among high school runners in Table 2? Well, you'd add up the person years, that total time at risk. So now you have 2 cases divided by 16.5. And that gives you 12.1 cases per 100 person years of observation. A little bit different, isn't it? So instead of saying that there were 40% or 40 out of 100, you would say 12.1 cases of patellofemoral pain syndrome per 100 person years of running or of sport participation. Here are some commonly used rates. I'm going to give you about 5 seconds of dead air here for you to pause the recording to allow you to read through these. Go ahead and pause the recording. All right. I'm assuming that you had a chance to take a peek through those. Depending upon what type of systematic review or scoping review you're going to conduct, you might have some of these reported in those papers. Let's take a look at the design of a prevalence study. People in a population are examined for the presence of the condition of interest. This could be a disease, this could be injury, or this could be a positive health state. Some have the condition at that point, others do not. Again, this is cross-sectional in nature. They're conducted at one point in time. Advantages. Good for describing prevalence and examining some associations. They're fast, they're relatively cheap to perform. Dropout is not a problem because you've collected all that data at one point in time. Serial cross-sectional studies can provide trends. And these are initial studies. They're the first step, often leading to more rigorous studies. Limitations, they cannot infer causality. They can't make statements about what preceded what. For example, in my study of the basketball players and patellar tendinopathy or patellar tendon abnormality, non-starters were at a greater risk. Or the odds were that non-starters were more likely to develop patellar tendinopathy. Well, what is unique about non-starters going on to develop it? Or maybe those who developed it couldn't perform as well, and they then were non-starters versus starters because they could not compete as well, jump as high, move as fast. See what I'm trying to say here? We were not able to infer. There's no temporal order. These also aren't good for rare diseases or those of brief duration. Because if you go to try to analyze if there is people that have that disease and it's of brief duration or it's rare, you might not capture people that have it. Here's an example of serial cross-sectional studies. If you do things at one point in time, maybe the prevalence of steroid use in Major League Baseball players in 1990 was 5%, but maybe over time that increased. And so you're able to see that trend over those repeated time periods. Again, strengths and weaknesses, they're important for planning health services. They provide valuable information about what to expect in different clinical situations. They're less time-consuming, they're inexpensive, but they're only weak evidence for cause and effect. Incidence studies, the population that is assessed is a cohort. The cohort is a group of people having something in common when first assembled, followed over time for the development of events, injury, disease, or other outcomes of interest. For example, I've done a lot of studies looking at Division III athletes, and so I might be interested in collecting a group of Division III athletes at the start of the season, all of them who were free of injury, and then follow them over the course of the season for time loss injury. Incident studies, again, also known as cohort studies. Other examples, individuals who are cancer-free until onset of cancer. Or all individuals may have recently been diagnosed with the disease and then followed forward in time for outcomes, for example, recurrence after treatment or death. This is an infographic highlighting the Framingham Heart Study. And have you heard of it? I'm sure you've probably heard of it. Going back many generations, where they have followed thousands of participants and published tons of papers, probably close to 4,000 now, based upon that large prospective cohort data they've collected. These types of studies are very time intensive, require a lot of money, a lot of personnel, and as you can imagine, they're not easy to conduct. The strengths of a cohort study, an incidence study, you're able to appreciate the temporal sequence. Did the exposure precede the outcome? You're able to calculate incidence rates, and you're able to study rare exposures. For example, adverse effects of a drug or unusual occupational exposures. You may have to follow large populations for a long period of time. These studies can be expensive, they can be time-consuming. They're not good for rare diseases. Let's say you're following 30,000 people, but the known incidence is 1 in 50,000. It's possible you could have put a lot of effort in and not followed enough people to be able to study the incidence of that disease or to determine risk factors of that disease. And loss to follow-up can introduce bias. All right, that is the end of lecture 1 here. So we've explored prevalence, we've explored incidence. Hopefully you have a better understanding between the two. Let me know if you have any questions.